let's stop and talk about the unit circle here because this is going to be really important. We're going to use the unit circle out pretty much throughout the rest of this course, so you need to be able to come up with this on demand. So what I would recommend is prior to each test is to print out a blank copy of the unit circle. You cannot fill it out though until you start testing. So what you would do is print out a blank copy, make sure it's completely blank, show it to the computer or to the web camera to make sure it's blank, and then once you start testing, then you can go ahead and fill it out from memory. And I'm going to show you how you can actually come up with the unit circle in case you go blank, and the only thing, if anything, that you should be memorizing is this first quadrant, if anything. The rest of it just comes straight from that first quadrant. And I'll show you kind of how to do this. But the idea is we're going to start out with some angles that we already know, that we've already talked about in previous sections. We'll start out with the first one, which is a 30-degree angle. The 30 is the smallest that we'll deal with, is a 30-degree angle, which is going to come from our right triangle that has the 30 degrees in it, which is the 30, 60, 90 triangle. Remember we talked about this a while ago, the 30, 60, 90 triangle. And what's opposite the smallest angle, the 30 degree, is the smallest side, which is 1. What's opposite the next biggest angle, the 60, is the next biggest side, which is the square root of 3. And the biggest angle, the 90 degree, has the biggest side of 2. And then what we can do is we can start talking about our trig functions, sine, cosine, and tangent. Why would we want to do that? Is because the points in our unit circle, our x's and our y's, are going to come from cosine for the x's and sine for our y's. So what does this mean? It means if we want to talk about cosine for our x's for the 30-degree angle, is we got to remember that cosine is your adjacent over hypotenuse. Well, from our angle that we're looking at here, which is the 30-degree angle, our adjacent, so we're looking from our 30-degree angle right now, our adjacent would be the one next to it, would be square root of 3 over 2, your hypotenuse. So for our 30-degree angle, our x-coordinate, our cosine, would be square root of 3 over 2. That would be our x-coordinate for that point. Now, to also look at the y-coordinate for that 30 degrees, well, then we'd be looking at our so-and-so SOHCAHTOA, which is our, our sine, which would give us so-and-so SOHCAHTOA, which would be opposite over hypotenuse. Well, the opposite from the 30-degree angle is the 1. Over the hypotenuse, we already said, is 2, which would give us a point for our y-coordinate for our sine value of 1/2. Now, the only other thing that they want us to fill in here is, besides the 30-degree angles, also filling that in radians, which, remember, you can do that by multiplying by a pi over 180 degrees, and the degree symbol will cancel out, and then all you have to do is reduce the 30 over 180, which will turn into pi over 6. So we can fill our angle of pi over 6. That's the same angle but in radians. Now let's look at the next angle. The next angle is actually going to be the 45-degree angle, which is going to come from the 45, 45, 90 triangle. So we can go ahead and draw that down below. So that would be the 45, 45, 90 triangle. And what we remember about the 45, 45, 90 is the sides on that triangle are 1, 1, and square root of 2. So what's nice about this is when we go to do our sine and our cosine, let's start out with cosine because that's your x value. Cosine is going to be our cosine, which will be let's see, it doesn't matter which 45-degree angle you actually use for that, but you're going to use adjacent over hypotenuse, which will be 1 over the square root of 2. And remember, we talked about this. You have to rationalize it by multiplying both the top and the bottom by a square root of 2, because you cannot leave a square root in the bottom, which will turn the top into square root of 2 over, well, the square root of 2 times the square root of 2 is just a 2. So remember, that gives you square root of 2 over 2. For your cosine or your x value. Then you'd have to do the same thing for your sine value, which would be your so-and-so katoa. That would be your opposite, which is, again, 1, over your hypotenuse, which is square root of 2 again. You'd have to do the same thing we just did, which is rationalize, multiply the top and the bottom by a square root of 2. So that you do not have a square root in the denominator, which will leave you with square root of 2 over 2 again. So 45 is a special angle that both its x and y are the same. And then you'd want to do the same thing moving along. Oops, before we do that, let's turn this into our angle into radians. So you'd want to take your 45 degrees, multiply it by a pi over 180. And let's see, the degrees would cancel. And then the question is really, how do you reduce the 45 over 180, which will give you pi over 4. And you'll start to see these angles a lot, so you may end up accidentally memorizing them. And that's okay. The next angle that we have on our unit circle here is a 60-degree angle. And that's going to come from our first triangle, but we're just going to look from the 60-degree angle. And we'll still do, let's see, the cosine first, which is adjacent over hypotenuse, but this time adjacent with the 60 degrees is going to be 1 over 2. So our cosine is actually going to be the 1/2 this time in the 60 degree. So you can probably guess that the sine is going to be, well, the sine is still going to be opposite over hypotenuse, which this time will be the square root of 3 over 2 for the 60-degree angle. So notice, once you have the 30-degree angle, the 60-degree angle is just the same, it's just the x and y are swapped. We also have to fill in this whole little quadrant. We need to fill in one more angle, which is the 60-degree angle, but in radians. So you can do that off to the side, which is that 60 degrees is going to be times pi over 180. And what will happen is, again, degrees will cancel out. The 60 over 180 reduces to 1/3, so you've got pi over 3. And we're almost done generating this first quadrant. The rest of the first quadrant is pretty straightforward. So the rest of the first quadrant is our special angles, which is the first one, which is when you don't go anywhere, which is 0 degrees, which is the same thing as 0 radians, because 0 times anything is 0. And this point is over here. It's only on the x-axis, so it's 1, 0. We talked about these quadrantal angles before. And then we've got the one up at the top and the end of the first quadrant, which is our 90-degree angle, which is, if you convert that into radians, multiplying it by pi over 180 will actually turn into pi over 2. And the point here would be 0, 1 instead, because there's only a y value. We're only going up. We're not going left or right. So this will be 0, 1. So this is the key and kind of what you want to fill in first. Everything else that's in our unit circle will kind of be a take off of the beginning, this first quadrant. Let's